Hey guys, welcome back. We're gonna keep looking at similarity here. So here, in number 3, it has us look at these different problems. So it's telling us that we have this triangle. If we look at A, we have triangle JKL, and then it has kind of squiggly line. I'm zoomed in so you can't really see it very well. But it's saying those two triangles are similar. So again, if you see this symbol, that means that it's similar. Okay, so now it's asking us to find the missing length. So here we're looking at finding this mystery length right there. So another thing with similarity is how it's written also gives us a very good understanding on what is similar. So here if we look at triangle JKL, and it has the squiggly similar to the triangle TUV. So the way this is written, it means that angle J, so this angle here, is similar to angle T. So those two guys are similar. And then K, right here, do 2 lines because it's a different angle. And that's similar to angle U. And lastly, L is similar to V. So we'll do 3 little arc thingies here. So those 3 angles are all similar, but also this helps us in regards to identifying which lines are similar. So the way it's written also gives us a good understanding. So here, JK, so this side is going to be similar to TU, so that's this side here. So what we just learned about proportions is if we call this guy x, we can write this as x over 90, but now we need to know something else in order to be able to solve this proportion. We need to figure out and set up another side. So again, the triangle helps, or the notation helps us to see. So if we have KL, that means this line right here, the side, is similar to UV. So it would be this one right here. So that'll help us set up the ending of this proportion. So let me change my colors back here. So we did x over 90. So now what we'll have to do is we have this 12. And so that's equal to 12 over, and what does it correspond to? 54. So we'll have 12 over 54. Now again, we got to use our proportions, be able to solve this out, and so we're going to use cross multiplication. So we'll do 12 times 90, x times 54. That one a little easier than the 12 times 90. That one will just be 54x, and that's equal to 12 times 90, which is 1080. Now we want to solve for x, so we just divide by 54, divide by 54, and so then we get x is equal to, hey, this one comes out to be pretty, 20. So we get x is equal to 20. So looking at, hopefully that makes sense. Please let me know, just email me, reach out, let me know if you have any questions. If we look at this next triangle, so we know on B we know that U is similar to U. So these angles here are both similar. Angle V and K are similar, so we're going to have V and K. And then W and L. Nope, gotta do 3 lines here. And we're wanting to find this mystery length right here. But again, we know looking at the notation that UV, so this length right here, is similar to UK, so this one right here. So we could set up a proportion on that. We could go, let's go with the bigger one on top. Let's go 84 over 18. It's important, guys, that you keep that same order. So we use the triangle UVW side first, right here. And so now we're using that other number right there. And now we're wanting to know what length of UL is. So also, we know that UW is going to be the same as UL. So UW gives us 98, so now it's going to be equal to 98, and then to UL, that's going to be over X. And then we can just solve that by cross multiplying. I'll post these notes filled out on my website so that way you can see if you got that right. Other things you're going to see with this are, for example, D. We got a triangle within a triangle. So when we see something like this, that means that these triangles are going to be similar. Why? Because if we look at this angle right here, that's going to be both in the triangles BSC, but also in TSU. And that guy doesn't change. That's going to be the same angle no matter what. And then if these points, as long as they are along those same lines, this angle CBS, or just angle B, is going to be similar to angle UTS or angle T. Then likewise, we've got to do 3 here. These ones are going to be similar. So we could write this, that triangle, let's go, nope, wrong letter, Mr. Rainey, TUV, that's similar to triangle. Again, we got to do the same order. So we did T, so that means we got to go B first, so B. Then we did U, so we got to go to C. And then this is S. And you guys are probably saying TUV, silly Mr. Rainey. Gotcha. Just wanted to see if you were paying attention. So that would be TUS. So those two triangles are similar. So we can use that to help us be able to find this proportion. So we're wanting to know BS. So BS is going to be similar to TS. And so if we do BS and just have that be X, we can create a proportion over 77. That's equal to, we can use any one of these other sides. Let's go CS and US. So CS, the length is 15, just right there, over CS, which the length was 55. And we'll cross multiply right there. Get 55x is equal to, what's that number? Looks like it'd be 2,310. Nope, that's wrong. Heh. Silly Mr. Rainey, that's wrong. Let's figure out what that is. Sorry, pause while I get a calculator. Okay, so that would actually be 1,155. We divide by 55 here. Let's see what that gets us. So we would get x is equal to 21. Okay? So give those other examples a try, guys. We'll go, that way you can get some extra practice there. And I think we'll call it that for this video. Just wanted to give you some practice. We'll move on to something new in the next one. Okay, see you guys.